Today we're going to look at series circuits. We're going to do practice A, and we're going to do problem number 1. And I'm going to go beyond. So when I start solving for more stuff beyond what they ask you, the reason I'm doing that is because I want to show you how in circuits you have a foolproof way to always check your work as you go along. So it says a 12-volt storage battery is connected to 3 resistors, respectively. The resistors are joined in series. So first of all, there's no picture. I'm going to draw a picture because most of us are visual, and a picture really helps us to conceptualize. When we do circuits, we don't call it a picture, we call it a schematic diagram. So on the test, on an FRQ, I might actually ask you to draw the schematic diagram. Okay, and that might be worth like 2 points. So to draw the schematic diagram, this one has 3 resistors. Now, why am I drawing them like this? What if instead I drew them like this? And then let's say I had the battery, over here. Could I do it? Is this and this the same thing? It is. Because in series, remember, there's only one path for the current to flow. So here, the total current's flowing through here, and the same thing is like this. So these actually are the same thing. I'm just going to use this diagram. It doesn't matter. So I'm going to label my resistors. To me, it's important to label the resistors, even if they don't label them, because it helps them when I'm doing the math. So I'm going to call this one R1. So this is 6.75 ohms. I'm going to call this one R2, which is 15.3 ohms. And I'm going to call this one R3, and that's going to be 21.6 ohms. And they told me in the given, so in the given they gave me those 3 values. They told me R1 was 6.75, R2 was 15.3, and R3 was 21.6. What they also told me is that the battery is equal to 12 volts. So I call the battery VT. I call it V for total, so I know that's like the battery, but to call it total makes it easier. So what do they want us to find? First, they want us to find the equivalent resistance. Now, I call that T for total because I just use T as a subscript for everything. Okay. They also want us to find the total current, so I'll call that IT. So where do I start? Well, they want me to find the equivalent resistance. So they want to know what is instead of having 3 resistors in series, what if I had one resistor that was equivalent to those 3? Well, we know that in series, and this is the equation that we learned, that RT is just equal to R1 plus R2 plus R3. Okay? So that's all I do. I say RT is equal to 6.75 plus 15.3 plus 21.6. So when I add that on my calculator, RT comes out to be 43.65 ohms. And that's it. So again, today we're only going to do series circuits. The next part says, part B, what is the total current? So here's the thing about circuits. We're going to use Ohm's law that we learned in the previous chapter. But here's the thing about Ohm's law. I can use Ohm's law for the entire circuit, or I can use Ohm's law for one part of the circuit. So what I'm going to do now is, I'm going to look at my given. I have VT. I want to find IT, and I just found RT. So here, this is applying Ohm's law for the whole circuit. So if I want to find IT is equal to VT over RT, which is 12 volts over 43.65 ohms. So the total current comes out to be 0.275 amps. This is where this problem ends. What I'm going to do is I'm going to go beyond on this problem because I want to teach and show you some other things. So when you do the rest of the homework or in the future, it'll make sense. Okay? So coming out of this battery, going through this wire, I know the total current is 0.275 amps. So that means the current going through here is 0.275, the current going through here is 0.275, and the current going through here is 0.275. Now remember the equation. The equation is IT is equal to I1 is equal to I2 is equal to I3. So on the quiz that we're going to have on series and parallel, let's say I was then to ask you what is I1, what is I2, and what is I3? Well, in series they're all equal, so I don't need to do another calculation, right? Now, what if I asked you V1, V2, and V3? Now, the equation that we know is that in series the voltages add up. So what that means is the voltage drop across each resistor is going to add up to the source. So what we're going to do is we're going to use Ohm's law again, and we're going to find the voltage drop across each resistor, and we're going to see that it adds up to our source, which is 12, and that's a foolproof way to check our work. So what do I mean by that? So as we apply Ohm's law, for the first one, I'm going to say V1 is I1 times R1. So 0.275 times 6.75, that comes out to be 1.86. I can find the voltage drop across the second resistor. V2 is I2 times R2. So 0.275 times 15.3, that comes out to be 4.2 volts. This is volts. Sorry about that. Plus this green marker, I need a replacement. Then, if I do V3 is equal to I3R3. Now, they're not asking me for this. I suggest you write it down because I'm showing you a foolproof way to always check your work. So V3 is I3 times R3, which is 0.275 times 21.6. So on this calculator, this comes out to be 5.94. If I add these up, it should add up to 12. And it should add up to this. So what I'm doing is I'm looking at another one of my equations, and again, I have a foolproof way to check my work. Okay? So when you're doing circuits, at the end, and I could say, even though they didn't ask me for this, I could say, well, I want to make sure I didn't make a mistake. I can go back and find the voltage drop across each resistor, and it should add up to the source. As far as circuits is concerned, the math really isn't hard. What you're going to be doing is you're going to be applying Ohm's law either for the entire circuit or for each little part of the circuit. Okay? And that's it. But what you do have to memorize is, like for today, we need to memorize, and we're going to have to memorize this for the test as well, that in series, the resistances add up. We have to know that the current is the same throughout the circuit because there's only one path for it to flow. And then the last thing is that the voltage of the source is equal to the voltage drop across each resistor. So as far as series is concerned, this is all we need to do to understand how to do all these problems. Okay? Now this is on the chart in your notes, but here's the thing. When we do the homework, I asked you to write the equations for every problem. So even though all 6 of these tonight are series, if you write this for every single problem when you're using it, are you going to forget it? That's what helps you to remember stuff. You know, when you write stuff down, like equations, and you keep writing and writing it, it helps you to remember. So that's why on your homework, you're going to, again, every time you use these equations, you're going to write them down, and then you'll remember them. And that's it.